So here's the related theorem for the curvature. Another way to do it, not necessarily easier, but this is something you can prove actually, and I think also the book is giving you the proof of this one. If you take the magnitude of a cross product between the first and the second derivative of the vector, the space-scale vector, so r prime cross r double prime, you take that magnitude and you divide it by the magnitude of r prime raised to the cubic power, then this will give you the curvature. You can see in terms of dimension, you have a vector square here and divide by a vector cube. So at least the dimensions are pretty straightforward. Let's talk about normal, binormal, and tangent. When we are already talking about tangent, let's talk about normal and binormal vectors. So I have a couple of definitions here. The notation, of course, is n. And I'm going to say that n, and it's a vector, and we can express it as a vector function, n of t. By definition, it will be t prime, the vector t prime, the derivative, divided by, can you take a guess what they're going to divide by? So, is it, what's the length of this vector? 1, it's unit length. Remember, so is the tangent vector. The tangent vector, r divided by r by its magnitude. I'm sorry, r prime divided by its magnitude. It's a unit vector. So, and actually, we usually treat the tangent, the normal, and binormal as a package deal. Binormal vector defined as the following. It will be b of t for binormal, and it's a cross multiplication. So it will be the tangent, the unit tangent vector cross the normal vector. So this gives you an idea what is the direction of the binormal. Well, one thing we know already, that the normal is orthogonal with the tangent, right? So if you have a curve like so, and you pick at a point where you have a certain value of t, okay? So the tangent will be this vector. So this is t, and again, this is a unit vector. The normal will be a unit vector, so it will have the same length such that it's perpendicular to the tangent, because the normal is always perpendicular to the tangent. So what's up with the binormal? Well, this is a cross product, so the binormal is orthogonal to both t and n. So in which direction will we see it? Well, we'll see it upward in this case. And it will be this vector, again, unit vector, and this is the binormal, such that it's 90 degrees to t and 90 degrees to n, like so. Okay. And this is the vector, this is the curve C. So, yeah, I see you doing the hand thing. So, again, be careful in the Middle East, don't try to do it, but if my thumb is T, Okay, look at the cross product. It's T cross N. And this is not commutative. T cross N is not the same as N cross T. N cross T will give you the opposite direction. But you keep the order T, N, B. T cross N gives you B. So if this is T and T is a tangent to the curve, N will be perpendicular to T, and B will be perpendicular to both. So thumb goes to index, goes to the middle. Okay? Like so. All right. I think I'll stop here.